Collection framework: storing, retrieving, and manipulating objects. Collection: when we need to store objects, we can use an object of a class in the collection framework. For example, an array list is a class which is implementing an interface list, and it can store objects in an ordered manner, in the sense we can access it by index. So at 0 position is, say, magenta, and 1 red, and so on. Collection framework: a collection is an object that groups multiple elements into a single unit. It is used to store, retrieve, manipulate, and communicate aggregate data. A collection framework is a unified architecture for representing and manipulating collections. The framework has interfaces, their implementations, methods for computations. The benefits are: it reduces effort to design, learn, code, increases program speed and quality. Collection hierarchy: collection interface is the root of collection framework. List, set, and queue are interfaces which extend the collection interface. List is an ordered collection. Objects can be accessed by index. Set does not allow duplicates, and queue stores in the first in, first out order. Abstract collection class implements collection interface. The abstract list implements list, and abstract set implements set, and abstract queue implements queue. The concrete classes are tree set, hash set, array list, extending the appropriate classes which can be used for storing objects. Map stores key value object pairs. The concrete implementations like hash table, hash map, tree map. Hash table is thread safe, null not allowed. So this is the architecture hierarchy. Map is the interface, hash table, hash map, and tree map are concrete classes. An array list example. Task is to remove the elements from a list, those elements that exist in another list. For example, we have a vehicles array, which is a string array, and we would like to remove these two, Jeep and bike, from the above. So first we make an array list, which is a list, and in a for each loop store everything in the vehicles array into the vehicle list array list. Add vehicle. For each vehicle of type string in vehicles, add vehicle into the vehicle list. Similarly, create remove vehicles list, and the solution will be like this. Vehicles.iterator will return an iterator, and in a while loop, iterator has next. Remove vehicles contains iterator.next. So by each of the next element, if it is present in remove vehicles, iterator.remove. So this will remove the original object. So for example, here now it finds that Jeep is present, so the iterator is connected to the Jeep, and you say remove, so Jeep gets removed. Similarly, bike gets removed. Let us run it. We have a class ArrayListTest. We have two string arrays, one is vehicles and one is remove vehicles. So from this array we need to remove Jeep and bike, so these need to be removed. So first we create array lists, vehicle list and remove list, and into vehicle list add all the vehicles in the vehicles array, and into remove list add all the vehicles in the remove vehicles, and we say remove vehicles. Both the vehicle list and remove list are passed on as parameters into this method. So first we get iterator from the first list, that is the vehicle list, and in a while condition iterator has next, keep on doing it, iterator.next, check in the other list, contains the element, and then remove. So compile it first. Java C. We see that these two have been removed from here. Then we print the list after removing the second array elements. A linked list example. The task is to manipulate elements using a linked list. We have a string array, mobiles 1, with 4 values, and another string array with 5 different values. Create a linked list, which is a list, and add all the values from the first string array. Similarly, add all the values from the second array into the second list. Solution: first combine the lists by calling the add all method of the first list and passing the second list as a parameter. To convert to uppercase, use a list iterator method. It returns a list iterator, and in a while loop, iterator has next, which returns a boolean. Iterator.next returns the element one by one. set it back after converting to uppercase. To remove elements, say index 4 to position 7, call the method sublist 4, 7 and call clear method, which will remove the elements as required. To print in reverse order, list iterator and give the size of the list so the pointer goes to the end of the list, and use the method has previous in a while loop to fetch the elements using previous. So let us check the example. We have string array 1, 2 and 2 lists which are linked list. Populate the first list and populate the second list from the first and second string arrays. List1.add all list2 ensures all the values in list2 is added to list1. Dereference the second one, which is not required anymore, so that the garbage collector takes care of this object, and print the list1. To convert to uppercase, a list iterator returns the list iterator from the list, has next in a while loop, and call the next to return the string, and do uppercase and set it back. Again print the list, remove items, sublist start to end and clear. Then print reverse list. Again call list iterator up to the size so the pointer goes to the end, and use has previous in a while loop and call previous, which returns the element in a backwards manner. So let us run it. As we can see, the combined list after uppercase, after deletion, so 4 to 7 deleted, and the reverse list. Using a set to store strings. Task is to create unique collection of strings. So we have a string array colors, which has a set of colors. To convert this into a list, use the class arrays and the method as list, passing the colors array to it. It returns a list. To store non-duplicates, create a hash set, as we know that set is unique, and pass the list to it. Let us run the program. So class set test, we have a colors string array, use arrays.asList, pass colors to it, it returns a list, and to get the non-duplicates, simply pass the list to the hash set, it returns a set, and print them. Run it. So we see that all the duplicates have been removed. For example, orange. If we need to store emp objects in a set, and we would like to have a unique collection, that is without repetition, again create a hash set, add the emp objects to it, and to determine the uniqueness, let us say we would like these numbers to be unique. So the emp object has to override hash code and equals. So hash code, let us return age, and equals, we will compare the ages of the two objects. So we can see that Willie, John, Hanif and Lucy are stored because there are repetitions here, 27 and 49. Both of them are not stored. Let us test. We have a class setEmpTest, create a hash set and add all the emp objects. The emp object has the hash code and equals method overridden. So the hash code returns an age and equals compares the age. So the hash set uses the hash code and equals to ensure that there are no duplicates. So as we can see, 27 is repeated, 49 is repeated, and these two are not added because they already exist once it's added. Test it. We can see that Willie, John, Hanif and Lucy are added. These two are not added.